Hello everyone, in this video tutorial, we will learn how we can create a chatbot for our own website using Llama 2 and LangChain. So this is the complete architecture diagram for our chatbot, how we will design this chatbot. But before I discuss this architecture diagram, let me show you one thing. So guys, I have just launched a LangChain course in which I will be building 12 large language model apps using OpenAI and Llama 2. So here the course content details are provided over here, and all the project details which we will be building in this course are also provided. And here you can check the description of the course, a more detailed overview about the course. And you can check out our other courses as well. So you can see we have multiple object detection courses available with latest state-of-the-art object detection models, which include YOLO-V7, YOLO-V8, YOLO-NAS. Along with this, 1,466 students have enrolled in our courses, and we have 4.5 rating out of 5. So this is a new course which I have launched one day back. So here is the course, and the course is available in $10. The link of the course is available in description. Do check out this link and let me know your thoughts. So let's discuss the architecture diagram. So you have, every one of you know that in a website, we have each website contains multiple like URLs, or each website have multiple pages. Okay, so our website can have 20, 30 or 100 pages as well. So now if you want to create a chatbot for our own website, we need to have access to the data available on these pages. So first of all, we need to know how many pages are there in our website. To get this information, so for example, if I just want to know how many pages are or how many URLs are in the OpenAI.com website, so I will just write sitemap.xml. So sitemap.xml gives us the information of all the pages that we have in the website. Okay, so now you can see over here, here are all the URLs provided of different pages that we have in this OpenAI website. So you can see, and we have so many pages in this website. You can see the long list of URLs. So you can see that all these URLs are available over here of different pages we have in the OpenAI website. So in the similar way, you can check out other website as well and check out how many pages you have in those website, and you can also find out the URLs by writing sitemap.xml. So you can see here we also have the URL, and this is the URL. So you can see that all the pages URLs are being provided over there, and the change frequency, like the content change frequency on those pages, are also provided over here. Daily and priority levels are also provided over here. Okay, so in this tutorial, I will be showing you that how you can create a chatbot for your own website. So using sitemap.xml, we can find the URLs of all the pages that we have in the website. So first of all, now if I just go zoom, okay, so I have just zoom in. So now you can see over here using sitemap.xml, I will get the information of all the pages that we have in the website. Okay, and we can find the URL for those pages as well using sitemap.xml. So after finding all the pages that we have in the website, I will extract the data from all those pages. Okay, so I will be extracting the data from all these pages, and then I will be dividing this data into chunks. Okay, so here I will be extracting data from all these pages. So okay, so I will be extracting the data from all these pages, and I will be just splitting the text which we get into chunks, splitting the data or text into small chunks. Okay, so from sitemap.xml, we have the information like different URLs that are in the our website or different pages that we have in our website. Then we will extract the data from all these pages. Then we'll split the data into small chunks. Okay. Then we will create embeddings for each of the chunks. So embeddings are what are basically embeddings are, you can say that embeddings are vectors which contains floating point number. So if we just want to compress the size of our text, we can just convert the text to floating point numbers using embeddings. So embeddings are vectors which contain floating point numbers. So now you can say that we have the embeddings like this 0.1, 0.3, 0.9. Okay. So we will create embeddings for each of the text chunk. Okay. So this is how embeddings look like. So first of all, we extracted data from all the pages of the website, and then we will split the data into small chunks. Then we will create embeddings for each of the text chunk. Okay. So so now here you can see that we have created embeddings for each of the text chunks. Okay. So now after creating embeddings for each of the text chunks, then we will store the embeddings in the knowledge base. So we will just create a knowledge base where we'll store all these embeddings. Okay. We will build semantic index and then we will store the embedding in the knowledge base. So knowledge base is a vector store, or you can say that vector database. Okay. So here we'll be using FICE vector store. So FICE is basically Facebook AI similarity search database. Okay. So here you can see that we have stored all the embeddings in our knowledge base. Okay. So we have all the information that what kind of data is available in our website. So in this knowledge base, we have all the information of all the data that is available in the website. So now here is the user. When the user asks a question, we create embeddings. When the user asks a question, we create embeddings for the question that the user has asked for. So here we are just creating embeddings for the question that the user has asked. So now here we create embeddings for the question that user has asked. Okay, so after creating embeddings for the question like your user has asked, I think it's already available. So here you can see, for an example, these are the embeddings of the question that the user has asked. So now after creating embeddings of the question the user has asked, we will now do a semantic search. So in the knowledge base, we will have all the information stored, like what kind of data is available in our website, and this in the knowledge base, this data is being stored in the form of embeddings. Okay, so now we have just converted the question into embeddings, which is a floating point numbers. So now we will do semantic search. We will try to find the answer of this question from the data available in the knowledge base. So and then we'll rank the top 6 answers which we find from the knowledge base. You can change this value to 1, 2, 3. So you can just find top 3 answer, top 4 answer, but by default it find top 6 answers that are available in the knowledge base for this question. So after finding the top 6 answer, I know in the next step I will pass the user question directly to the large language model as well, and we will find the top 6 responses to the large language model as well, which is Llama 2 in this case. And the large language model will then generate a natural response, and we will get back it will be forwarded to the user as well. So this is the complete architecture diagram of how it works. So let's move towards the code part. So in the first step, you will install all the required packages. So we will install LangChain package, accelerate, transformers, sentence piece, and sentence transformers package, because we will be downloading embedding sentence transformers embeddings in this case. So we will be using free embeddings, and we will be using sentence transformer embeddings. Okay. So plus I will also be showing you how you can do this with Llama 2, as well as how you can do this with OpenAI models as well. And here I'm installing unstructured package so that I can extract the data from those URLs. Okay. And here we are installing FICE CPU because we are using FICE as our knowledge base or vector database. Okay. So along with this, you can also do this with Pinecone client, but in this tutorial, we will be focusing on FICE as our vector database. So here I am just importing all the required libraries, unstructured URL loader, so that I can pass all the URLs of my website. Okay, and then we will split the data getter from those pages in the website into small text chunks using vector text splitter. And then here I've used the OpenAI embedding. So I will be using OpenAI model as well to convert the data into embeddings. Plus I will also use free embeddings from Hugging Face embeddings as well to convert the text chunks into embeddings. So here I have Chat OpenAI fast as our knowledge base. We can also use Pinecone as our knowledge base, but we'll focusing on FICE as our knowledge base. And then we have Retrieval with source chain, so that this will give us the answer to our question with the source as well, like from which website or which URL it has gathered this information. Okay. Then we have Hugging Face embeddings to convert our text into embeddings. Okay, text chunks into embeddings. So now we have auto tokenizer so that we can convert our text into numerical array. And then we have Hugging Face pipeline so that so there are two ways to assess the model from Hugging Face. So the Llama 2 is also available on Hugging Face. So one way is to assess the model through API. I tried to assess the Llama 2 model through API, but it did not work. The second approach is to download the model in your Colab or download the model locally. So I will be downloading the model, Llama 2 model from Hugging Face into this Google Colab notebook, and then we will be creating a pipeline. So network notebook logging, then we have why we do notebook logging, so that we can assess the model's private repos from the Hugging Face. So that using notebook login, I will be able to download the Llama 2 model from Hugging Face. Then we have text wrap. So I just use text wrap so that I can clean the text generated. So I can clean the response generated by the Llama 2 model. Then I have sys SYS. So why we just need this? Because if I just want to stop the process, I will just use sys package. Okay, then I have OS package. So using OS package, I will just create an environment. Okay, and then we have Torch, and then we have NLTK. So I'm just downloading NLT toolkit so that I can just extract the text from those website. Okay, and here I've just passed the OpenAI API key so that I can just create an environment so that I can use OpenAI models in this Google Colab notebook as well. So OpenAI models are not free. They have some cost associated with them. So you need to have a paid account in OpenAI. You just need to have a paid account so that you can access OpenAI models. So that now you can see that here I'm just passing different URLs. So let me just show you these URLs one by one. So I will be extracting the data from these URLs, and then I will be just creating a chatbot. So it will be able to answer the questions. It will be able to answer from the information that is available on these URLs. So first of all, you can see this URL. This URL contains a blog on Llama 2. This is recently written blog. So here we have information about Llama 2. So I will be extracting the data from this blog. First, the next URL is this. This is a blog on latest model. MPD 7 with 7 billion parameters. So let me just show you. So here you can see this is a blog on latest large language model MPD 7B. So 7 billion 7 billion parameters. So here we will also extract the data from this website, and we will do a question answer as well. So next is we have this blog on stability AI. So here you can see we have a blog on stability AI, and Stability launches the first stable LLM, large language model. Okay, so this is a blog on other large language model. So we will be extracting the data from this page as well. And then the last, we have the blog on the also recently launched large language model, YOLO-NAS as well, which is launched in March, not very recent. Okay, so this is a blog on YOLO-NAS, an open source chatbot replacing GPT-4 with 90% chat GPT quality. So we will also extracting the information from this blog post as well. Okay. So now here I have just passed all these URLs. So okay. So now I will be just extracting the data. I will use a structured URL to load these pages and extracting the data available on these pages. So this might take few seconds. So you can see that we are able to extract all the information that is available on these pages. So here we have extracted all the data that is available on these pages. Okay. So next, what we just need to go is we just need to split this text into text chunks. So you can see that currently we have four URLs. So you can see that 4 URLs. So we have divided our data into 4 parts. Okay. So now you can see that we will need to divide our text into different text chunks, because you can see that Llama 2 model has an input token limit, or input token limit basically represent 1 token is equal to 4 English characters. So it has input token limit of 4096 tokens. Or you can say that if 1 token is equal to maximum 4 characters, so it has in the input to the Llama 2 model, you can pass 16,000 English characters at the input maximum. So you can just by maximum you can pass 16,000 English characters at the input of the Llama 2 model. Okay. So now if you just see this extracted text, so we have more than 16,000 characters, English characters. So we cannot pass this text directly into the input as an input to the Llama 2 model. So we need to divide this text into chunks. So here I've just set the chunk size as 1,000. So we will divide this complete text into text chunks, which will contain 1,000 characters at maximum, and there will be a overlap of 200 characters as well. So let me just show you. So let me just show you the overlap concept as well. So if you just see over here, Llama 2 model. So if you see Llama 2 model with 7 billion and 30 billion parameters outdo MPT models of small size in all character code benchmarks. So here you can see that this complete line is also added over here as well. Okay. So you can see that. So this is an overlap of 200 characters in this text chunk and this chunk. Okay. So now I will just download Hugging Face embeddings. Okay. So I will also show you how you can do this with OpenAI embeddings, but currently we will be using Hugging Face embeddings, which are free to use. Plus I will be using Llama 2 model, which is also open source model and free to use as well. Okay. So now you can see that we have downloaded Hugging Face embeddings. So if you just want to check the embedding size or index size, so you can just check the dimensions of your embedding. So you can see that we have 768 as the dimensions of our embeddings. Okay. So now I will be just creating a, you can say that vector database or knowledge base. So now you can see that we have converted our text into small chunks. Like you can see that we have 89 different chunks. So we have done till this part. So we have created our extracted. We have extracted the data from 4 URLs. Then we have converted that data into small chunks. Okay, so you can see that we have 89 different chunks. Okay, so now we just need to create embeddings for each of the text chunk, and then we will create a knowledge base where we will store all these embeddings. So now what I'm doing over here is I am just converting these text chunks into embeddings and creating a knowledge base. So here after we have downloaded Hugging Face embeddings, so now I'm just converting those text chunks into embeddings. And then I am just storing those embeddings in the FICE knowledge base. So we are just using the knowledge base as FICE. So we have FICE as our knowledge base. So FICE is our knowledge base. Okay. So FICE represents Facebook AI similarity search these things. Okay. So now here we are just converting our text chunk into embeddings and storing those embeddings into our knowledge base, which is FICE. Okay. So we are using FICE CPU as our vector store. Okay. So now we have done this. So now what I will do is I will just do a notebook logging. So I will show to assess the model from Hugging Face, you need to have your Colab connected with it. So I will just huggingface.co from here, and I will just go to settings from here and just go to assess tokens from here. Just copy my assess token and just paste this over here. So that's work good. Then click on login. So you can see login successful. So now I will be able to download a model as well as tokenizer from Hugging Face website. Okay, so model. Okay, so I've already downloaded it. So I think I just need to restart my runtime so that I can just download it. Okay, no issues in that. So just import all these libraries again. So now I will just do this as well. We don't need to log in again. It works. Now you can see that we are just downloading the tokenizer as well as Llama 2 model on here as well. And we are by default, it downloads a 16-bit model, but here you can see that in my GPU, I have 15 GB graphic card. I don't have the paid subscription of Google Colab, so I have 15 GB graphic card available. But if you have a paid subscription model, so it offers 40 GB graphic card. So You can just get the prescription if you want. So, but I have prescription model. So I have to consider my memory usage. So I am just using 8-bit over here. By default, it uploads 16-bit model. So I'm just uploading 8-bit model. You can also load 4-bit model, but it gets very not good results. So I will be using 8-bit model over here. Okay, so now it's downloading the model, so it might take few seconds before it is ready. So now you can see it's worked. Now I'm just create a pipeline and maximum new tokens. It means maximum number of tokens in the output. One token is equal to 4 characters in English. Okay, so now here I'm just creating a pipeline, and if I just ask, please provide. Okay, so just change this. Please provide a concise summary of the book Alchemist. So let's see what response do we get from here. So this might take few seconds before we are able to get the response. So here you can see we get the concise summary. The brief summary includes plots, key elements, and themes. Paulo Coelho tells the tale of Santiago, a shepherd who embarks on life's altering adventure in quest of his personal legend, his innermost desire, which can be fulfilled only when he listens to his heart. Santiago sets from the pyramids of Jigs, follows a series of signs and omens to fulfill his personal legend. Along the way, he meets various people who teach him and spirituality, self-discovery, and perseverance. When he reaches the oasis of Ziora, he discovers Fatma, the love of the life, and he learns about the importance of staying true to one's heart and spirit. So you can just find a summary of the book and Alchemist or any other book. So now this is just checking how our Llama 2 models working. So now I will just going back to our original tutorial. So now I'm just asking a question: how good is Vicuna? So if you just see that I have just passed this URL as well over here about Vicuna, which is this URL. So I'm just asking the question from this website: how good is Vicuna? So if now if I just go below down, so in the way it uploads. So let me just execute this cell. So let's run this. Okay, so I'm just asking a question from this website, which is Vicuna. How good is Vicuna? So Vicuna is an open source chatbot impressing GPT-4 90% ChatGPT quality. So I've just extracted the data from this website as well. I showed you. So now I'm just asking a question as a chatbot: how good is Vicuna? So you can see that currently it's running. So this might take few seconds before we get the answer. So let's wait. And as I get the answer, I will show you, and then we will discuss some further questions and ask some further question as well and see what results do we get. So now you can see that I have asked how good is Vicuna, and here is our answer. Vicuna is a large language model that has 90% capability of ChatGPT, but it still has limitations. Okay. So you can see that here we have this sign. So if you just wrap the text, so this sign will be removed and you have a more clean answer. Okay. So now you can just ask, how does Llama 2 outperform the other models? So you can just ask this question as well. So let's see what response do we get for this. So this might take few seconds before we get the answer. So here is our answer. Llama 2 model outperforms other models in various benchmark categories, particularly MPT, Falcon, and open source model. They are also compared favorably to closed source models like GPT 3.5 and Palm as well. So we have the answer. So just clean this text a bit and show you the response for this as well. So you can see that Llama 2 outperforms other models in various benchmark categories. So it's a quite clean format. So let's ask, what is stable LM? Okay, so I'm just asking this question now. So this might take few seconds before we get the answer. Now I have just asked what is stable LM, and here we answer stable LM is a suite of language model developed by Stability AI. So it's a clean answer. And if I just ask, can you please share some details about MPT-7 model? So it says I cannot provide more information on the MPT-7B model as the requested article does not provide enough context or information on this topic. So in this way, you can also do a question answer like you can see over here as well. So let me just show you a quick overview how you can do this with OpenAI models as well. So here you can see that I've just passed my OpenAI API key over here. So now I will just go down below. Okay. And one thing I will change is I will just download OpenAI embeddings from here. Okay. So either we use basically three embeddings. So now I've just downloaded OpenAI embeddings as I will also use chat OpenAI models in this case as well. Okay, so this is Initialize. So let's see what by default which model it uses. So let's see that. Okay, so by default it's using GPT 3.5 turbo model. So that's okay. Okay, so if you just go below down and ask this question, please provide a concise summary of the book Alchemist, and let's see what response does it give. Okay. Here I just missed the dot predict. So I just added the dot predict function, and here we have the summary. The Alchemist is a novel written by Brazilian author Paulo Coelho. It follows the journey of a young shepherd, Santiago, who sets out to find a hidden treasure after having a recurring dream. So here is the concise summary. You can copy it from here as well. So let's establish the chain and let's ask the question. So here is our answer. Vacuna achieves 90% capability of ChatGPT and its qualities on or par with ChatGPT. It has limitation in tasks involving reasoning or mathematics and may have limitation in factual accuracy. But with OpenAI, you can see that it performs better than Llama 2 and gives us a more detailed answer as well. So that's good as well. So let's go ahead further and let's ask compare how does Llama 2 outperforms other models, or let's see what response do we get from here. So this will take around 5 to 6 seconds more before we have the answer. So here you can see that we have the answer. How does Llama 2 outperforms other models? Llama 2 model outperforms MPT model of similar size in all categories except word benchmarks. And they also outperform Qualcomm models in all benchmark categories. The 70 billion parameter Llama 2 model achieves improved results on the MMLU and VBH benchmarks compared to the Llama 1 model. So here you can see that we have a detailed answer over here as well. And if I just ask what is stable LM, and stable LM is an open source model released by Stability AI. This model is available in various parameter sizes. So you can see a quite detailed response over here as well. And if I just ask, can you please share some details with about MPT-7B model? You can know that with Llama 2 model, it was unable to generate a response, but here it is. The MPT-7B model was built by the Mosaically ML NLP team using the tools available to use to every customer of Mosaic ML. It was trained on the Mosaic ML platform using tools such as Compute A100, 40GP, A100, 80GP from Oracle Cloud. So you can see that here we have a quite detailed answer over here as well. So now we can do a complete question answering over here as well. So if I just write how word is, so let's see what response we get from here. So this might take a few seconds before we are able to get the response. So here you can see our complete chatbot working. Vacuna has certain limitation. It is not good at tasks involving reasoning and mathematics. However, after fine-tuning with shared ChatGPT configuration, Vacuna becomes capable of generating more detailed and well answer. How does Llama 2 outperforms other models? So let's see what response we get for this. And This might take 2 seconds before we are able to generate the response. So let's see. Okay. Yes, Llama 2 outperforms other models in various benchmark categories, except for code benchmarks. Llama 2 model is 7 billion. Here we have a detailed response. Okay, so if I just write exit from here, or let us, what is table? So this is the last question I am just asking. What is table LM? And after this, I will just writing exit, and I will be able to exit. There is no relevant information. Okay, if I just want to answer how big is table LM. So let's see. Okay, so let's ask, can you please share some details about MPT-7V model? Okay, so let's see what response do we get from here. So this might take 2 seconds, and let's see. The MPT-7V model was trained on the Mosaic ML platform using tools such as 840GB, 880GB GPUs from Oracle Cloud for Compute. So here we have a clear answer. If you just write exit from here, we are just exiting. So that's all from this tutorial. I hope you have learned something from this tutorial. See you all in the next video. Till then, bye-bye.